Hello learners, hope you're all doing good. So in the last video we have discussed the structure of the Verilog. In today's video we are gonna learn how to code for an AND logic gate. So AND is one of the primitive logic gate we all know. So now we are gonna try to code and then analyze the output for AND logic gate. So firstly I'm gonna create a file by right clicking on the project window, going to AND project, then new file. So here I'm gonna give the file name as AND gate. Remember guys, I usually use the same file name on the module name so that I won't get confused while getting simulation. So change the file type as Verilog and okay. So now the file has been created. Double clicking on the file, we can edit the file. See, now the first step, if you recollect the previous video, content from the previous video, then we can see that the first step for coding is like module definition. So I'm going to define the module and gate. See, I'm using the same name as module name and the file name. So why am I not using just and is that you have to remember that and is a keyword in Verilog. So if you give the keyword in Verilog, it doesn't accept. So it throws a compilation error. So I'm going to use as and gate or and g. So you can notice the difference. See, now the AND gate module name is in highlighted in black color. So when you give AND, the AND is colored in red now, so indicating that it is a keyword. So be careful of the keywords, and then followed by the outputs and the inputs y comma a comma b. So here I'm considering my y as output and then a and b as input. The next step in the structure of Verilog is input and output definitions or declarations. So I'm going to give my inputs a and b and then output y. So next the logic. So the logic can be implemented in three different ways in Verilog. One is gate level, the other one is data flow, and then the other last one is final one is behavioral modeling. So for this AND gate, I'm going to demonstrate the gate level and the data flow modeling. So in gate level, since gate level modeling, what you are supposed to do is like we are gonna use the keywords to get the output. So since AND is an keyword, we are gonna give the keyword and then the syntax is such a way that first you have to mention the output and then followed by the input. So this statement in the line number 4 and of y comma a comma b gives us the logic operation of a and b, logic and operation of a and b, and the result of that and operation will be assigned to y. So this is with respect to the logic. Now we are done with the logic, so we are gonna close the module. That can be done by giving end module. See here the keywords are end module and output input module. These are the keywords in this particular program. So I'm gonna mention it here. This is gate level modeling. Okay. So now I'm done with the coding. So I'm gonna save the file. You can save the file by going to file and then save, or you have an option here next to the new file under the view. Here we have save option. I'm gonna make a change over. Yes, see now we can see the number highlighted, icon highlighted. So I'm gonna save the file, and then the status is unknown. So since we haven't compiled yet, now I'm gonna compile it. So right click, compile selected. You can see the result in the transcript. So here compilation was successful. So you can also notice that in the project window, the compilation status symbol has also changed from unknown to compilation successful. So now we are gonna simulate and then analyze the result. So go to simulate, start simulation. As soon as you click on start simulation, a window pops up. Here what you're supposed to do is go to work. Okay, so you can expand the work by clicking on this plus symbol, and then you can see the file name andget.v. So andget, okay. So now next to the project window, you can see a simulation window is gonna pop up. So while popping up multiple screen flashes, like multiple tabs flashes, do not worry about your system. It's just the how software works. So once you get a simulation window, what you're supposed to do is like you're supposed to add wave. So add wave. So what is add wave is like, once you give add wave, all the inputs and outputs, a wave will be assigned. So you can give the values for these inputs, and then when you run the program you can analyze the output in the form of wave. So the simulation window has been popped up, so I'm gonna right click on it and then give add wave. You can also give this by giving control W. So add wave. See, in the now the wave window appears. So here, see, initially there were no inputs and outputs in the waveform window. Now we have A, B, and Y. So the thing is, in we can give the values. Usually, what engineers do is like we write a test bench, and then in the test bench we initialize the values of the inputs, so that when we run for a particular time period, entire thing, like for all the inputs, the output will be generated. Since we are at the early stage, without writing test bench, I'm going to show you how I can give the values voluntarily while simulating. So what you're supposed to do is like, you can, in the waveform window you can see the select lines A, B, and Y. So right click on A, then you can see the option called force. Go to force, and then here change the value to 0. Okay, and then it asks for the B also give it as 0. So y is something I will put, we don't need to give that. So now how are we gonna run it? So at that, if you can observe at the top, there's a run length tab. So next to the run length there's an icon with down arrow. So when you click on that, it runs for the particular time period. So you can see the waveform has been generated for 100 picoseconds. So here you can, when you click on it, a cursor will be shown, and then here the we can see the values of A and B during this time period. So we have given A as 0 and then B as 0, and the output logic is 0. So now I'm going to change the value to value of B to 1. So right click on it, force, and then give it to 1. Okay. Now I'm going to run it again. So what happens, you can see the transition of value from 0 to 1 for B. So when you place the cursor on 0, 1, the logic is 0. So now I'm going to give A as 1 and then B as 0. Force 1 and then B as 0. See again, you can see the transition of values of A from 0 to 1, and then value of B from 1 to 0. Still the logic is 0, which is true according to the truth table. So now I'm gonna give both the values as 1 and 1. 4, then 1, and for 100 more seconds. See, now the you can see the values are 1, A is 1 and B is 1, output logic is also 1, which is same according to the truth table. So this is how you simulate a particular code in Verilog. So once we are done with the simulation, we can end the simulation by going to the simulate tab and then click on end simulation. Give yes. And then we are back to the project window tab. So now we are done with the gate level modeling. So how do we modify the code with respect to the data flow modeling? So I'm gonna comment the logic of the gate level modeling. So in data flow modeling or continuous assignment operation, we usually use operators. So what are these operators? These operators are a symbol that indicate the logic. So in Verilog, for the operation and, the operator we use is ampersand. You can see it in the line number 5 that I've typed. And then for or, what we do is like, what the symbol that we use is or. And then for XOR we use the symbol, and then for negation or NOR input we use the symbol this. These are the symbols that or the operators that we use. And then for the left shift or right shift, we use the following operators. So this is all with respect to the operators. So how do we define the operations? Like we assign particular value, we assign the logical value to that particular output symbol. So what we do is like we use the statement called assign. So assign is one, again another keyword. Assign, what are we assigning? The output, the output symbol is y. So assign y is equal to and operation of a and b. Since the and operation is defined or indicated by the ampersand symbol, ampersand of a and b, it's pretty straightforward. So we are going to assign and we are going to perform and operation between a and b, assign it to the value y. So this is data flow modeling. Data flow modeling. So now I'm going to save the file, and now we are going to compare whether the output is similar to gate level modeling or not. We can observe over here it should be similar, because we haven't changed any logic, we just changed the way we just changed the mentioning of the logic in a different way. So see, as soon as the file is edited, you can see the compilation, the status of the file is gone to unknown. So right click on it and then compile. Compile selected. Compilation was successful. Now we are going to simulate. Go to simulate, start simulation, and gate. Okay. Add wave. See, initially there were no operators like A, B, and Y. Once you add wave, you get the select lines A, B, and Y. Now we force the value 0, A as 0, B as 0, and then run it for 100 picoseconds. A is 0, B is 0, Y is also 0, A is 0, and then B is 1 is the next value I'm gonna give. Run it. Same 0 and 1. The output hasn't changed. It is still 0. When A is 1 and then B is 0, Y is still 0. Now finally A is 1 and then B is 1. Y is also 1. So the output that we are getting is matching with the truth table. Hence the code we have done is correct. So I'm gonna end the simulation. So that's all for today. Hope you guys had great learning time. In further classes, we'll learn more about the other primitive gates, and then combinational circuits we'll learn, and then after sequential circuits. Hope you'll have a great learning experience. Thank you all.